So in this second part, we'll try to finish the abstract constructor pull request that we started last time. So the first thing is things have changed a bit. Yes, on master. So the our PR has been merged, and also we'll first get it, and then we fix the conflict that we have with abstract constructor. Master, yes, get the conflict, and readme is fine, and test, yeah, the tests have some simultaneous changes. Oops, did we say it was simple weighted graph? Alright, so the conflict is somewhere here. Yes. Okay, it's not too bad. But, is this? Yes, it seems to be a nested one. Okay. So we'll test the project from here just to check that the merge has been operated correctly, and then we'll do the last modifications that have been requested or discussed on the pull request. This is fine. Alright, so if we check the pull request itself, so we got a few comments from our contributors asking why is this happening. So we have one issue here which is not related to LightGraph or to the PR itself. And this one, which is about double allocation, it's a relevant one. We'll try to see if we can fix this. And the biggest one, I guess, it's yeah, that's a key thing that we want to modify here. Instead of returning nothing from the get index, to throw an error, because this is not supposed to happen. Okay. So yeah, there's this thing here that we haven't touched, and the rest of it is fine. So cool. So we can commit from here. Fix conflict. Okay. So now this is done, we can start with the real stuff, including simple weighted graph. Yes, we start with get index. So here we are using just one property of the edge, which is the source and the destination, and this is the basic interface for all the edges. So here we've been using a simple weighted graph edge, and if we import our light graph, we'll see that oh no, we also need to be using simple weighted graphs. Then a simple weighted edge is a subtype of, well, we'll check its super type, that abstract simple weighted edge. Okay, and if we get the super type of this one, that's abstract edge. And abstract edge itself is just an interface with source and destination. So this means here we just need to assume that the E variable or the E argument is an abstract edge and nothing more. So it's a light graph. No, I think we used all of light graphs, so light graphs, we don't need abstract edge. And we don't need a T or anything, okay. E is an abstract edge, and that's it. And yeah, that's the only thing we assume. Okay. And that's it for this one. Same thing in the SRC, simple weighted dgraph. We have the same thing here. Abstract edge, okay. So that's the first thing. And then we'll so here instead of return nothing, what could we throw? We could throw a method error, but this would be a bit awkward. Maybe, what's the definition for method error? Required type signature does not exist. This could do the job. There's no unique, no specific, no, it's not that. What we have is there is no method matching this type signature. And so in that case, this will be, there's no method matching val s where s is a symbol. Or we could just, yeah, we could just remove it and get an error when we don't get val weight. That would be fine. Yeah, and we'll do the same thing for graph. Nothing, yes, that's here. So we could just remove it. Okay. So that's going to be a second commit. Throw method error when getting property not edge, not weight. Okay. So that was the second thing to do. So this one will resolve later. Other than that, I think most of it is fine. We need maybe more tests. Yeah, well, first I guess we'll first push everything. Fork abstract. Yes. So now that this is done, I refresh here. This will take a while. Permute is not given in the doc string. That's in src simple weighted digraph. Simple digraph. Permute. Yeah. Directed graph of weighted type U. Note that I'm removing edges. Yeah, no, okay. Primary constructor takes sparse adjacency matrix as input. So maybe we could use something that is not exactly this data structure, which is a specific implementation of sparse matrices, column major to be more accurate. Maybe we don't need to be that precise, maybe we don't use that many implementation details, but I'm not sure here, so we'll just leave it as is. Which can optionally be permuted with keyword permute equal true. Okay. Oh, permute true is the default. That's interesting. I'm not sure this should be the case. Permute equals true, huh? And I also thought we did this here, all the formatting stuff. I will just leave this here. Okay. Okay, so this allows us to have a zero cost constructor, let's say, by just copying the weights. Yes. here we can just have some basic formatting. Yeah, that's something here. Actually, I could just copy things without repeating myself all over. Okay. Yeah, we are relying here on the fact that the matrix is column major, and what we take as the input is always inverted by default. So yeah, let's give it a shot. If we create sparse arrays, let's create a matrix as p0s with 4 and 3, and then n of 1, 2, 3, 2, 1, 4. Okay. If we convert this to a matrix. Okay. Now, if we create a simple weighted graph out of this matrix. Oh, this should error, maybe? Okay, yeah, no, it makes sense. We're supposed to have a square matrix because this is every vertex against every other vertex. Okay. Okay. Alright, so far so good. Simple weighted graph. Yes, okay, that makes sense here. We're supposed to have a symmetric one for graph, and for digraph or digraph. Okay. Adjacency matrix. Adjacency matrix of this graph is inverted. 3, 4, and we had no. This is exactly the same thing. Okay, interesting. So permute seems to be false here. Which one is called? Overrides 31. Okay. I'm not sure I like having an override file. It's a bit too generic, I think, but well. So adjacency matrix. Oh no, this is for adjacency matrix. I wanted which on the constructor. Simple weighted graph of a given sparse matrix at simple weighted digraph 22. We are not in the good file. Simple weighted digraph 22. Okay. Permute equals true. So we are calling it with permute equals true here. T is a float. No. No. Okay. And T is an int and U is a float. This thing again. So we're supposed to be calling this one. So if we create eg equals so floats int like this. Nope, yo, wait, simple weighted digraph at 12. Oops. So here, that's the main one. Permute equals true, so it's supposed to permute the dims of a matrix we get. And if you use this, is this in base? Permute dims, yes. Of n. Oops, no, it's n. Okay, so it's just transposed basically. And if we get adjacency matrix of, oh no, right? So that's correct. It's been transposed already. No. So M here is this, and the adjacency matrix is exactly the same thing. So we just permute it internally. dj dot weights. Oh, okay. So it's kept transposed internally, but then it's what is being stored is the transpose of the adjacency matrix. That's interesting. Maybe this should also be documented. Because for now, so the adjacency matrix is assuming Mij like this is getting the weight of the edge from vertex I to vertex j. And what the matrix is storing is the transpose of this, so that. Okay. So yeah, this should definitely be documented somewhere. A type representing a direct graph. So it should be documented for both types. Primary constructor takes as passages. Which is stored permuted. Of which the transpose is stored. To provide the transpose directly. The keyword argument permute can be used. Okay, it's maybe not great. I guess the best thing is to start a discussion on this, and then people will just jump on it on the pull request and say, hey, maybe we should phrase this a bit better or anything. So primary constructor takes as passages as the matrix input of which the transpose star. Okay, yeah, this is not Shakespeare definitely, but it should be fine. Yes, that's the comment here, indexed by DST is RC. Okay, and I guess it's not ideal either, but for now we can copy this to simple weighted digraph. Simple weighted graph, sorry. Oops, graph. Yeah, it's what has been done for the other thing, so. Okay. Yeah, we also have permute here, right? No, we don't. Oh no, we don't need to permute it here because it's supposed to be symmetric. So there's no permute business in the undirected case. Still this thing. Okay. So here we go. Yes, and we'll keep formatting things as we go. Okay, so for now this is already simplifying things quite a bit. Okay, what else? So permute is now mentioned in the docstring. The other point that another contributor raised is with permuted go true, we're allocating matrix. So yeah, we're providing a matrix to this type. But the thing is, we're only providing the matrix in the constructor, and for what we need, we will always need the matrix. And I guess the constructor is a bit signaling, hey, I'm consuming this matrix and I'm gonna be using it. So don't modify, don't mutate the matrix in other places, because this there's gonna be the same matrix pointer. It does make sense. So in any ways, I guess you just you're supposed to just provide the matrix and then leave it as is, not assume it's not usable anymore. So we have a double allocation, one for multiplication with x and one for the transposition afterwards. Maybe there's a more efficient way, yeah. So that's for the initial weights, and this is at line 62 of which file is this? Simple diagraph 62. Okay. That's not correct. Yeah, I don't like these comments on top. They can confuse you. Also, maybe this U should be a W instead to indicate weights for the weight type. Yeah, we'll just put this as a doc string. Abstract graph. Default weight. Are we keeping consistent with the U being a real and the T an integer? I believe not. Okay, I hope we are, but it is not. Okay. Construct, oops. Digraph. Digraph. Initial. Weight. X. From our graph G. X. Okay. Oops. Graph. No typo. Okay, we're fine. So the question from Simon was, are we having a double allocation that we could avoid somewhere? Yeah, maybe we should transpose here, and transpose, oops, and then return simple weight with this times m, and permute equals false. I think the permute keyword was used as an optimization initially to avoid copying when we don't need to. This here is not correct. This should be okay. I hope, yeah, we'll check if this is tested later, or maybe we'll do it now. So the signature here is creating a simple weighted diagraph from any graph and a weight. Okay. Yeah, we'll create a test now. Simple weighted graph. Yeah, maybe we should have something separate for the diagraph, I'm not sure. we have some things here. Okay. Simple weighted digraph, path digraph, and 2. Oh, so this is tested already. Yeah, so maybe we made the test fail, but in any case, this is tested. So it might take a few minutes to get all the dependencies. Oh, and there we go. Oh no, this is even worse. Syntax error. Not in where. Okay. Where did we do that? Simple weighted graph. Here. Oops. Oh yeah. Okay. Well, I guess we just did this once. So we'll see basically if we messed up the constructor by permuting when we didn't need to, or not permuting when we had to. Maybe. Oh yeah, right. I tested that this typo here was returning nothing. So instead we'll just, now we know that we threw an error, method error. Oops, no, that's in the tests. And that's simple weighted graph, I guess. Yes. I always forget using tests. How do you test throws? Yes. How do you use that? Oh yeah, test throws, the error, and something. Test throws. Method error. We don't need to compose nothing anymore. And where is the other? Yes. No. Okay, that was the only one. Okay. Do we have equal nothing? Nope. So where was the other one? We have 2 tests failing. Simple weighted graph 231 and simple weight. Yeah, I think that was here. Let's rerun the tests. So this stream is a bit more tedious than other ones because we have, oh cool, we have more, let's say, maintenance to do and more constructor things to watch out, or yeah, more, we're managing more code that we have not written before, and so there are lots of elements to browse in this thing. But the good thing is it's an open repo and it's a real world project that's been used by many people, and so it's basically contributing to something that I'm not really familiar with, or not completely familiar with, so it's a good thing, I guess, to have. So I guess we can cost constructor. Yep, not origin fork. Okay, so this has been addressed now, so I'll answer Simon later. All right. So this has been addressed, and I think we're getting in pretty good shape now. Most of the things we needed to do are done. What I don't remember is, was the cut coverage good or not? No, we were decreasing the cut coverage. The bad thing is we can't see it now because Travis hasn't run completely yet. So this means we don't have yet which lines are not covered by tests, and we need this to know where exactly we need more tests to cover the whole modifications, all the modifications of the code. Okay, so I guess for now this will be it. I'm still not gonna touch the LG compress format things because it's a bit more tricky. Yeah, other than that, we'll stop there for now.